students. This is a video related to the topic areas related to circles. This is a part 1. Here I'm going to deal with the problems based on perimeter of a circle and a part of a circle. Before going to the exercises related to this chapter, you must be knowing about few terms related to the circles. Like, you must be knowing about the definitions, about the important terms related to the circle, important properties like angles and lines, and important circle formulae. Let us discuss the terms related to circles. I have drawn a circle here. Now, the terms related to circles are center, radius, diameter, circumference, arc of a circle, sector of a circle, and semicircle. So, what is the center of a circle? If I am going to draw a circle, this point, central point O, name it as O, this is known as the center of a circle. The center of a circle is always at equal distance from the boundary of a circle. This is, wherever we go, this is always at equal distance. Generally, we name the center as a O. Now, what is the radius? Radius is the distance from center to the boundary of a circle. I am naming it as OR. OR is a radius. Now, what is the diameter of a circle? Diameter is the line which passes through the center of a circle. It always passes through the center of a circle. These all lines are the diameter of a circle. It is passing through the circle as well as it is cutting the circumference at 2 points. A, touching, it's not cutting, it is touching the end points are lying at the boundary of the circle. If it is a C or D, CD is a diameter and C end point and D, you can see the end point C and D are lying on the boundary of the circle. So this is the diameter of a circle. The property for the diameter of a circle is that diameter is twice the radius. If radius is 3 centimeter, then diameter will be double of 3. That means diameter will be 6 centimeters. If radius is 4 centimeter, diameter will be 8 centimeter. Now let us discuss what is the circumference of a circle. Circumference is the boundary of a circle. The line which makes up the circle is known as the circumference. And generally we denote the circumference as C. The formula for the circumference is 2 pi r. The value of pi is 22 by 7. 2 into 22 by 7, this is the pi value, and r is the radius. So circumference is the boundary of a circle. Now comes the arc of a circle. Now let us take some examples here to find out the areas which looks somewhat like that. First of all, you have to see which area we need to find. Suppose we need to find the area of this shaded portion. This one, the dark blue part. Let it be first figure. This is the first figure. And then here we have to find out the remaining area, this one. So you can see there is a circle outside this boundary. This is a circle. From the area of circle, if you are going to subtract the area of a square, then you can easily find out the remaining portion area. This is how we can find out the area of this shaded portion. Now come to the second part. Suppose we need to find out the area of this green part, green region. So this is again very simple. There is a square outside the region and under it there is a circle inscribed into it. So what you can do to find out the area of the remaining portion, which is the green part here. So in this way you can subtract from the area of a square to the area of circle. So area of a square is what? Side into side. So from this area, we can subtract the area of this circle. So the area of the remaining portion will be like that. Now how to do? When it is given the figure? When it's given the figure like this, Suppose we need to find out the area of the red portion here. Okay, so how you can do? Again the simple one. You can see the outer region total, this complete circle is there, and then there is a quadrant. You can say if it is a 90-degree, then it can be a quadrant. If it is having a certain angle, then it will be a sector of a circle. So how to find out this red part area? So the area of the red portion, I am writing area of red portion. This will be the area of circle, which is the pi r square. Area of the sector, area of the segment, this I'll tell you further. Before, I'm just giving you the hint how you can find out the areas. Now the area of the red part is the area of circle minus area of the quadrant. If it is 90-degree, then it will become as a, this sector become as a quadrant. Quadrant means 1/4 of a area of a circle. 1/4 of a circle is the quadrant. So easily you can find it out. So this is like, if you can easily solve this one. If we are going to solve, then this will come as 3 pi r square upon 4. Okay, now but if it is not the quadrant, if it is a sector, then how we can find out this area of this red portion? Area of red part. So what will be this area? Area of the circle, which is pi r square, minus area of the sector. Sector will, you must be given some angle so that you can find out the area of a sector. Area of sector. Okay, now the next part of it. Suppose we need to find out the area of this yellow region. This whole yellow part. So this is very simple. Again, from this area of circle, we will subtract the area of triangle, and then we can find out the area of the yellow region. But suppose we need only to find the area of the segment. Now let me write it. Segment part, if I am coloring it as, let me color it red so that you can see it easily. I am coloring it as red. This segment. Suppose we need to find out the area of the segment. Now how to find out the area of the segment? For this, you need to see figure like this. You can see this much portion from here to here. This is a sector. So what you have to do? Area of sector. Area, I'm just writing area as A. Area of sector minus area of triangle. Because this much is the sector. This is the sector portion. Isme se triangle will come like this. If I'm making it as a red triangle. So from the area of sector, you can subtract the area of triangle, which will be half base into height. Area of triangle is half base into height. If it is given as base and height, then you can find out. But there are one more formula I would like to tell you. So let's see. If it is at a certain angle, then height, how to find out. So when the angle at the center is 360 degree, 360 means complete rotation, area of the circle is pi r square. When the angle at the center is 1 degree, then the area of the sector becomes pi r square upon 360 degrees. But when the angle at the center is theta degree, like here, you can see this is a sector having certain angle theta. Suppose this much is the theta angle. Okay, let me name it as theta. So the angle at the center is theta. Then the area of the sector becomes pi r square upon 360 degree, जो कि हमारा 1 डिग्री के लिए था. pi r square upon 360 degree. थीटा के लिए क्या हो जाएगा? pi r square upon 360 degree into theta. So general formula, area of the sector when the angle at the center is theta. So area of the sector of a circle of radius r becomes what? Theta upon 360 degree into pi r square. Now, when the area, to find out the area of the segment of a circle, I have already told you how to find out the area of the segment. But when the you can see it is having an unknown angle here, theta, or whatever the angle may be given to you. So area of the segment is what? You can see area of the segment, this is the segment portion. A, C, B, this arc length and this chord length. Under this region, this is the segment. Let me color this so that you can see it properly. This is the segment. So how to find out this segment portion? This is, you can see from the area of sector. What is the sector? Let me draw it once again. From this area of sector, I have subtracted the area of triangle. Then we got the area of the segment. So this is what I have written here. But how to find out the area of triangle? Because it is not showing like any height or any base. It is having certain angle. The general formula for the area of triangle is what? Half base into height. So base, let me take the triangle. This I have drawn the triangle. Let me tell you how I have taken the triangle. This is the triangle. Name it as O. It is named as B here. So naming it as B. This is A. O to A, O to B is the radius R. Now, this is the angle theta. It must be given to you. Okay. Let me write it nicely. It's not looking as a theta. Taking a pen. This is an angle theta. So, if I'm drawing a perpendicular from B to this triangle, from vertex B to the base OA, if I'm taking OA as a base, height will be B to E. Let me name it as E. B to E is a height. Now how to find out this height of a triangle? So you can see, for this you have to go to the trigonometry. Sin theta is how much? Sin theta is perpendicular or height upon hypotenuse. Okay, what is the hypotenuse here? The side opposite to 90 degree is the hypotenuse. The side opposite to 90 degree is what? O to B. This is the side opposite to 90 degree. So sin theta here becomes sin theta is equals to what? P. P means perpendicular, which I have drawn here. B to E. Let me take this one. B to E. Okay, so sin theta becomes P upon hypotenuse means height, which is BE upon hypotenuse. Hypotenuse is how much here? O to B. O to B. So sin theta is BE upon OB. So BE is what? Height. So let me leave this height. I multiply this sin theta with OB. OB is what? R. Sin theta, this is R. This will cross multiply and then you can get the height BE. So this is how we can find out the height of this triangle. So this I have written here half base. Base is what? I have taken the base as O to A. This is the base and height. Height is what? OB sin AOB. OB sin AOB. OB means what? Hypotenuse, which is OB, and sin AOB. Sin AOB is what? Sin theta. Okay. So this is how we can find out the area of the minor segment. Now, for the major segment, how we can find out the major segment area? You have to subtract from the area of the complete circle to the area of the minor segment. And in this way, you can get the area of the major segment. Same way, we can find the length of the arc, length of an arc of a sector. So, what is the length of an arc? Suppose I draw a circle like this. I just need the length, arc length. How much arc length? Let me draw it. Name it as A to B. Okay, this is the arc length. I am showing it as a small l. A, B. This is the arc length. O is the center of a circle. So this is again angle theta. Now how to find out the arc length? The same way. If I draw a circle like this, it's making a complete rotation. Complete rotation means the central angle is 360 degree. So when the angle at the center is 360 degree, the arc length is 2 pi r, because when I'm moving from here, this point to this complete round, this is covering the boundary, and this becomes the total arc length. What is the total arc length? This is the boundary of a circle, and boundary is what? Circumference, which is 2 pi r. So when the central angle is 360 degree, the complete arc length is 2 pi r. Okay, when the angle is 1 degree, the angle, this arc length becomes 2 pi r by 360 degrees. And when the angle at this sector is theta degrees, then what will be the arc length? When the angle is 360 degree, the arc length is complete circle 2 pi r. When the sector angle is 1 degree, then the arc length becomes 2 pi r upon 360 degrees. When it becomes the theta degree, same way the unitary method, the arc length becomes theta upon 360 degree into 2 pi r. For 1 it is 2 pi r upon 360, for theta it is 2 pi r upon 360 into theta. Let me write it once again. 2 pi r upon 360 into theta, which is the formula here. So this is how we can find out the length of an arc of a sector. Okay. So I have told you the formula, it had made no difference if you have taken like here, both formulas are a little bit same. Area of the sector becomes, what is the area of the sector? That was theta upon 360 degree into pi r square. But the arc length, the length of an arc, it becomes the length, L-E-N-G-T-H, let me write it. At an angle theta, it becomes theta upon 360 degree into the arc length is what? 2 pi r. When it is length, it becomes 2 pi r. When it is area, it becomes pi r square. So this is all how we can deduct the formula and how we can find the length of an arc of a sector. Thank you to everyone.